Welcome back to Breaking Down Storage Tech. Today we are breaking down the NoisyMIS by Rapscallion, Expector Talon, and Command Leo. This sorts items up to hopper speed with a 40 game tick delay between item types and can sort 54 different items per slice, including 64 stackables and 16 stackables. So let's get straight into it. So the NoisyMIS. What is a MIS? Let's start with that. A MIS, or multi-item sorter, sorts multiple different item types, or for example, in this case, redstone, and we could also do something like observers and up to 52 to fill up this entire double chest, regardless of if it's a 16 stackable or a 64 stackable, and it puts it all out into this singular hopper right here, as opposed to fixed item filters, which only allow one item through. Now, why is this called the NoisyMIS? Well, there's a bit of history here, because these people, specifically Rapscallion, have been developing a series of MIS, or multi-item sorters, up to the MIS 5.1, which I do have a previous video on. But this is the MIS called the NoisyMIS because they decided to see what happens if they stopped caring about it being silent. And in turn, they were able to get it slightly smaller by reducing a dimension here and a dimension over here and a dimension in terms of height. So now this is 2 by 6 by 6 instead of 2 by 7 by 7, which the MIS 5.1 is. Now this is slightly slower than the 5.1 with a 40 game tick delay between item types instead of the 16 game ticks, but apart from that, it is just a lot more compact. And it's a really helpful and useful example, especially when you want to make compact storage systems. So let's get straight into it, shall we? So up here we have this chest right here. This is how we calibrate, or how we decide what our filters are. Now, we will not be inputting items directly into this chest. This is for pre-filling purposes. So we want to have 2 of every single item type, and this goes for 16 stackables as well. This system cannot store unstackables, but it will not break if a 64 stackable is placed into it. Where the items are actually put into is this hopper right here, typically with the hopper going into it like this. Now, the reason we do that is that this hopper has the variable filter, so that way it can pick up one item and the hopper underneath it can be unlocked and we can start filtering items. And this only allows one item type. So instead of having no items in it, and what happens is you place one item and then this chest starts to get empty, we will only pull item types or items out if they match the same item. So in our case, if we place the redstone dust, or any item for that fact, it'll fill this hopper right here. Now what then happens is we have the 2 tick delay of this comparator being updated, because we now have this hopper is filled. Now this comparator is in subtract mode, because if we look over here, we have a redstone signal strength of 1 coming from this comparator coming through this barrel right here with just a singular item to subtract away, so we can have our signal strength filter. Because with this hopper layout, just a single additional item, regardless of what it is, it will add signal strength to here. But as it is right now, it will only give a signal strength of 1, meaning it does not power anything over here. Now, the reason none of these items are getting pulled out is, I previously mentioned, this hopper is locked by this dust. Additionally, I should also mention this hopper is also locked by this redstone dust coming from this comparator, coming from this composter right here, to lock this hopper to make sure it doesn't pull any items. So what will actually happen is once we input the item, into this hopper, we will update this comparator. Once the item makes its way into this hopper, this comparator will power, and this will power these 2 pistons and this dispenser, as well as updating this observer with the 2 tick delay. What ends up happening is once this gets powered, we have the delay of these pistons extending, updating this repeater 2 ticks later, to then, as soon as this unpowers, this observer will trigger, because the 2 ticks delay of this no longer receiving a signal from this redstone block being moved gets added onto by this observer with this 2 tick delay from getting the update from the comparator to power this redstone line for slightly longer to keep this hopper locked, and once it does, it will pull an item. But this is done strategically in parallel with the 2 ticks coming from this comparator right here to unpower when this composter gets moved. Because as soon as this starts to move, this comparator will no longer be able to read it, meaning it'll have its 2-tick delay before it unpowers this redstone wire. So this happens very similar in time, but not exactly. This redstone wire will unpower before this redstone wire unpowers. The reason we do this is so that way we have our one item here, and this hopper will unlock just slightly before this one, so that way we can pull a matching item type because it'll match the redstone dust in this hopper. Quickly after, what then will happen is this redstone wire will unpower, allowing the item to get pulled down into this hopper, and because this hopper is not on cooldown, it'll also pull it immediately into here, going into its 8-tick cooldown. Now both items won't be removed instantly because this hopper still has its 8 game tick cooldown. Once we move this hopper or composter out of the way, and this hopper has been allowed to pull the singular item, we shortly after use the same composter moved up here to update or power this composter to allow us to take a reading, to then repower this same redstone wire with the signal strength of 1. Now this is done to relock this hopper, so that way this redstone dust right here can't get pulled from anymore, or any of the items can't, and we can't mess up the set. Now what ends up happening is we actually also power this dispenser like I mentioned earlier, and what's happening here is we have a powdered snow bucket inside it to get placed. Now this does not count as a toggle state because this works for both the powering and then the sequential powering for placing, and then the other powering for the picking up of the snow bucket, because both of them send observer updates down their respective lines, so it's not a toggle state. What ends up happening is once we place it, we power these two lines, as I obviously just mentioned. I'm going to talk about these in sequential order based on the order that they happen. So what happens is we have the powdered snow that gets placed right here to update this observer right here. Now when this observer gets updated, it will send a power for 4 game ticks later to go to this repeater, as well as 2 game ticks later updating this observer. Once we have this update queued and this update queued, when this one gets powered, which will be 2 game ticks later, 2 game ticks before this powers, this will then update at the same time because of the update or the delay of the observer, causing this observer and this repeater at the exact same time. Is we have this observer right here powering as well to power this dropper and power this hopper right here to lock it. Now 2 ticks later, the next obvious signals are this observer and this observer to power this hopper right here, as well as power these 3 observers. Now what ends up happening is the item, or the first item that we were talking about that makes it all the way down here almost instantly, once the 8 ticks are up, it makes its way into this dropper, and because we lock this hopper underneath it for 4 game ticks, the 2 from this observer and the 2 from here, it does not get pulled down, in turn allowing us for when we power all of these lines to shoot it through this dropper, and this dropper, and then with the next update to go this dropper and then to here. This is where the other signal starts to become relevant, which is this observer right here. Now this observer gets updated by this observer, so 2 ticks. So this is happening at the same time this observer is happening, which then powers this wire to update this 4 game tick delay, which is now putting it around the same time as here, which we then have the 2 game tick delay of this repeater and this powered rail to power these 2 droppers. Now what ends up happening here is it allows us to power these 2 droppers to push the item back into the into the chest if it is an item. So what will actually happen is if this is in the set, as that's what we typically call the chest or the selected items to go into the filter or into the desired chest, we call that the set. If it is in the set, what will happen is it'll just get shot and it'll be placed in here. But if it is not in the set, what happens is it can just plop its way down into this hopper right here, and it can move on to the next slice. As you can see, if I decide to stack this, I pop this over here and this over here, as you can see, this hopper will now push into the next hopper with the chest being there. I can actually print this and show you. You can see the hopper pushes into this hopper, which is this hopper right here, creating the 2 A-B tileable slices. I'll just undo that so you guys can see a little bit better. That gets it done with the first item. But what about the second item that we pulled out? Well, by the time that this is all done and the 8 game ticks that this is up, it'll move down and then down into here, which will allow this comparator to unpower. This comparator unpowering will retract these 2 sticky pistons right here, allowing us to lock back up this hopper to prevent any more items from coming through. And we will also lock up these hoppers right here, but that has the added delay of this coming here. But we have the update of the observer to also lock this hopper right here by the time, because the delay of this hopper will be up. And then we have the item in here now waiting for 8 game ticks before it makes its way down to this dropper. And because these signals aren't firing anymore, this dropper right here, or this hopper right here is not unlocked. Because these signals right here aren't firing anymore, we allow for this hopper right here to be unlocked and pull the item down and move it into the chest as so. And that is the whole system. So now I'm going to actually run this system for you guys so you get a better visualization of what's going on. So now if I just click freeze, and let's first try it with a non-filter item. So this should end up on the other side. So what actually ends up happening is we start running it. We have 2 ticks of this comparator and we power these down, and obviously this repeater gets unpowered and this composter gets unpowered. But we keep this line powered slightly longer for this observer to keep it, so that we have just enough time to pull an item if we can, but in this case we can't. So then 2 ticks later, this bottom hopper unlocks, allowing us to instantly pull the observer down here, and this comparator locks back up to block this hopper, so that way we don't have any more signals going into here. Now if we go into the other side, this is where we'll see the snow get placed or retracted. In this case it's retracted, to then update these 2 observers. Now we see another step, 2 ticks, we see this one power and this one power, and this is at the point where this comparator gets unpowered, and we start running this closing end of the system to relock back up, because there is no more power coming from this hopper right here. Now we see again 2 more ticks, we see this firing in parallel with these 2, and 2 more ticks later, we see that this observer firing and this observer firing in parallel with this repeater to then power or lock this hopper. So we have the item in here that just got powered by this line. So if we see on the next tick, in the next 2 ticks, this should get pushed up all the way here, and then 2 more ticks to get launched all the way here, and then we have the 2 ticks of this unpowering. You can see here, bang, bam. This dropper now gets fired, and it's attempted to push into here, but it obviously can't. So it just gets pulled down into this hopper right here, and that is how it goes. Now I will just unfreeze this again, and then refreeze it so it can go through all of its processes. And now we're going to try with the actual item. This time, you have the 2 ticks, this powers. This system gets run, as we can see. And we get the second item right here. We then pulse it to get the items out, down into here, and we lock up back this hopper. Now on the other side, we are retracting, or in this case we already placed the snow block, and what happens is we have the observers firing all in unison to do the same thing we just saw. Oop. Power, it's up here. Power, now it's back up here. Now we have this other signal to then power here and place it into this chest right here. But now we have to worry about this, but because the whole system is done, we get it into this dropper, and then it just gets pulled into this hopper like so. So this is the NoisyMIS, a really great system, iterating on all of the knowledge that the developers have gained from the MIS 5.1 and all of the iterations they made of that. And it is just a work of art of how compact it is. There's just not a block wasted in this thing, and I don't really see how it could be more compact. Now, this is 2-wide tileable, but you can do a little bit of a trick to make it 1-wide tileable by just do a clone tool. Actually, if you can take all of this, what you can do is, if I move it and rotate it, because it is rotatable, what you can do is have it like this, and then pull down the chests or pull down the items like so. Just that way you have essentially a 2-wide tileable system if you then do all the wiring and stuff to make it so. Or essentially you have a 1-wide tileable, but keep in mind then you are also just doubling the length of the system. But I think if I just quickly erase this right here, I think the sacrifice of having a little bit of noise with this system is definitely worth it for what you get, because it is just so compact and so neat, and it runs amazingly. Now, it doesn't run exactly as fast as the 5.1, but I think it's close enough for how cheap this is and just how cool it is in general. So that is going to be it for today's video, guys. I really hope you enjoyed, and I'll catch you in the next one.